Proportions. This video will help you write a proportion and solve a proportion. Writing a proportion. Before we look at writing a proportion, let's start with a definition. A proportion states that two ratios or rates are equal. Let's take a look at an example to see what that means. If you earn $10 per hour, then you should get paid $30 for 3 hours of work. Since these rates of pay are the same, they can be written as a proportion. So we have these two rates, $10 per hour on the left here, and then $30 for 3 hours. Since these rates are the same, we can set them equal, and when we set two rates or ratios equal, we come up with this proportion right here, where we have the first rate equal to some second rate, or the first ratio equal to some second ratio. Now there are three ways to write a proportion. The first way is written, and most of the time this is what we use in mathematics, it's written as a fraction. $10 is to 1 hour is the same as $30 is to 3 hours. Now we can also write this kind of in sentence form. If we ever needed to write this in a paragraph or sentence structure, we could also write the proportion this way. $10 is to 1 hour as 30 hours is to 3 hours. And we can abbreviate the sentence even down further if we want to use colons. And when we read this with colons, we read it the same way. This would be read, $10 is to 1 hour as $30 is to 3 hours. Now let's take a look at an example that will help you understand how to write a proportion. Example 1. One box of cereal costs $1.50. The cereal is advertised as 3 boxes for $4.50. Write a proportion for these two events. Well, what we have here is rates because we're comparing things that are different. So we have one box of cereal and we're comparing that to money. So there's one of our rates, and the other rate that we have is 3 boxes for $4.50. So now we can write this in a fraction form, and so if we wrote these ratios, we can set these things equal. Since one box of cereal is $1.50, that's the same as 3 boxes for $4.50. We can write this as a proportion. So we would say one box is to $1.50. That's the same as 3 boxes for $4.50. Now, notice when I wrote this proportion, I kept my units the same. I matched the units. Notice I both had the boxes in the numerator and money in the denominator. It would have also been perfectly fine to put money in the numerator and boxes in the denominator. As long as I'm consistent, my proportion is still good. So either of these proportions would be correct for this problem. Now it's time to check your understanding of taking a written statement and translating it into a proportion. Go ahead and pause your video player now and do practice problem 1. When you're done, hit play to see how you do. Question 1. A 40-pound child receives 1.2 ounces of medication. A 50-pound child received X ounces of medication. Okay, so here are two, again, rates. We're comparing pounds to ounces here. So let's see, 40 pounds to 1.2 ounces. So we could write that, 40 pounds to 1.2 ounces. And that now has to be the same. Now we want to put pounds, since I put it in the numerator in the first one, I'll put it in the numerator of the second one. 50 pounds is to X ounces. And we could have had this switched around, ounces in the numerator, pounds in the denominator. Either way would have been correct. Now what we're going to see in the next problems is that we could take a proportion like this, and if we knew the given rate or ratio, which was 40 pounds to 1.2 ounces, we could go ahead and solve and figure out how many ounces of medication should be given to a 50-pound child in this case. Solving a proportion. Proportions are useful for solving problems where something occurs with a known ratio or rate. For example, the ratio 16 to 9 can be used in a proportion to determine that a 27-inch tall HD TV or widescreen TV display will have a width of 48 inches. So once you set up the proportion, it will look similar to something like this. If we were trying to figure out, if we had a 27-inch tall HD TV and we were trying to figure out how wide that had to be, we could use a proportion to solve that. And we could set it up one of these two ways. We could say, we've got our given ratio is 16 to 9. That's the ratio of the picture. And here it looks like the 9 is the width. And so over here we would also put 27 the width. And we could solve for n up there and find that it was 48 inches for a 27-inch TV, a 27-inch tall TV. We also could have reversed the proportion and said, 9 is to 16, and again, now here the width would be on top. 9 and 27 would be our widths, and then 16 to n, which in this case we could solve for and find that that's 48 inches. Now let's take a look at some examples that will help you understand how to solve for an unknown value in a proportion. Example 2. Solve the proportion n over 15 equals 4 over 3. Well, when we're going to solve these proportions, I think it's best to kind of think of these things as fractions. And we have this fraction n over 15, on the other side 4/3. Now, one thing that's kind of nice and convenient for fractions that are the same, like for example, if I take the fraction 1/2, these are two totally separate fractions, but I'm just going to use this as an example. If I take the fraction 1/2 and make that equal to a fraction I know that is also equal to 1/2, like let's say 5/10. When fractions are equal like this, their cross products are also going to be equal. And what I mean by cross products is if I take 1 times 10, that's a cross product, 1 times 10 on that side, that's going to be equal to this other cross product, 2 times 5. Notice in this little equation that I've kind of changed this fraction equal to a fraction. I've kind of changed this fraction equal to a fraction into a nice little equation down here. And you'll notice I get the equation 10 equals 10, a true statement. That works for all fractions that are equal. And we're kind of given in this example too that this fraction on the left is equal to this fraction on the right. So what we can do is we can take the cross products and set them equal. So I could say, okay, here's this cross product, n times 3. Well, we'll probably write that 3 first, so that would be 3n. And that is going to be equal to this other cross product, 4 times 15. Now I have this nice little equation, and I can solve that equation for n. So let's see, 3n is equal to 60. Divide both sides by 3. And we'll see that n there is equal to 20. Now let's go ahead and check that out and make sure that that's okay. So what I'm saying is n is 20, so it would say this, that 20/15 is equal to 4/3. And that is true. You'll notice in 20 and 15, there's a common factor of 5 in both 20 and 15. If I was to divide that 5 out, if I divide a 5 out of 20, I would get 4. And if I divide a 5 out of 15, I would get 3. You'll notice these two fractions are the same. So what we can do is every time we're solving a proportion is we can kind of just take a look at those cross products and set them equal. Makes it a lot easier to solve for a proportion. Okay, example 3. To make lemonade, Cassandra follows a recipe that calls for 3 lemons to make 2 quarts of lemonade. If she follows this recipe and uses 24 lemons, how many quarts of lemonade can she make? Well, so here we have a rate, and we have a given rate here. Do you see this right here? It's 3 lemons. Takes 3 lemons to make 2 quarts. What we want to do now is we want to put that into a rate. 3 lemons to make 2 quarts. Okay, so there's our given rate. And now what we're going to find whenever we're doing these proportion problems is we're going to have another rate over here, but one of those values is going to be unknown. So continuing on with the problem, if she follows this recipe and uses 24 lemons, how many quarts? So there's our unknown. How many quarts? We're kind of given how many lemons here. So 24 lemons. Since I had lemons in the numerator of this rate, I want to make sure I put the lemons in the numerator of my second one. So there's 24 lemons. And we don't know how many quarts, so we'd say n quarts or whatever variable you want to choose. X quarts. Okay? So now I have my proportion set up. I can solve it. When we go to solve it, these units are not going to be handy. They're going to kind of be cumbersome, so we'll kind of remove the units. It's good to write them in when we're setting it up to make sure we get everything consistent in both ratios. But when I go to solve, it's going to be easier to just take a look at 3/2 is equal to 24 over x. Okay, to solve this, I would use the cross products. 3 times x is 3x, and then 2 times 24 is 48. Divide both sides by 3. And we solve for x, and we see 3 goes into 48 16 times. Now I want to make sure that I'm answering the problem that was asked, is how many quarts of lemonade does it take? I don't want to finish my problem here with x equals 16. I would say 16 quarts of lemonade. Now it's time to check your understanding of solving a proportion. Go ahead and pause your video player and work these two practice problems. When you're done, hit play to see how you did. Okay, question 2. Solve the proportion 3 over n equals 6 over 5. Okay, so we're just going to look at the cross products here. 3 times 5 is going to give us 15. N times 6, we'll write that as 6n. Okay, now I want to solve for n, so I would divide by 6, divide by 6. And so we're going to get a fraction here. I'll come over here a little bit here. So 6n divided by 6 is going to leave us with n. And on the other side, 15, 6, we can simplify that fraction. Let's factor 15. That's 3 times 5, factor 6. 2 times 3, common factor of 3 divides out. Leaves us with 5 halves. Now, depending on your instructor, 5 halves may be an okay to leave it improper. If it's not okay, then you would want to go ahead and change this to a mixed number. 2 goes into 5 twice with 1 left over, so that would be 2.5. So depending on your instructor, one of these answers will be correct. Okay, question 3. The nursing program at State College accepts 3 out of every 10 students that apply. If 250 students get accepted, how many students applied? So when I was reading this problem, as soon as I saw this, that the State College accepts 3 out of 10, as soon as I saw that, I thought, oh, there's my given rate here. Sorry, given ratio. So 3 out of every 10 students. So 3 accepted out of every 10 that apply. Okay, so there's my given rate. Now, if 250 students get accepted, so there's our other piece of information that's given. So 250 accepted, and again, I'm going to put that in the numerator because that's where I'm putting the students that are accepted in my proportion here. We want to know how many students applied. Well, that's our unknown, so we'd say X applied. Okay? And so again, we're going to solve this, and as we're solving this, we're going to kind of ignore the units there. So at this diagonal here, I'm going to take 3 times x coming across that diagonal, so I'd get 3x there. On the other one, I'm going to take 10 times 250, and so let's see, 10 times 250 is going to give me 2,500. Divide both sides by 3. Okay, so x on the left side all alone. 2,500 divided by 3. Punch that into my calculator. I get 833.3 repeating. So that's 83 1/3. If we had figured that out as a fraction, we would have come up with as a mixed number, we would have come up with 83 1/3. Now, there's no indication about how we're supposed to round in this problem, but it's asking us how many students apply. Okay? So right now, what our answer looks like is this: 833 1/3 students. I don't think that's appropriate when we're talking about a student. It would be kind of gross if we had 1/3 of a student applying. So we want to round this number to the nearest whole number because we're talking about people here, and so it makes sense to round it to the nearest whole number. So if we go back to our decimal answer here, 0.3 means we're going to round down. So we would want to say that 833 students applied. So we can also use proportions to find unknown dimensions of similar figures. So let's talk first about similar figures a little bit. Similar objects or figures have the same shape but may have different sizes. And if you take a look down here at my 2 triangles, these 2 triangles are similar. The one on the right is just a larger version of the one on the left. You can see their angles kind of all are the same, and the shapes are basically identical, except one is just kind of an enlarged version of it. So those are similar figures. So let's see, the corresponding angles of similar figures have equal measures. And so corresponding angles are just kind of the angles that match up in our picture here. So this angle here corresponds with this angle here. This right angle, or 90-degree angle, corresponds with this one. And finally, this angle in the front there corresponds with the other. And that's kind of how we mark the angles that are equal in measure. The one tick mark and the one tick mark go together, the 90s go together, and then the two tick marks go together. That's the way you indicate that or communicate that. Okay? So the corresponding sides of similar figures form equivalent ratios. So that's kind of a lot to take in, but when we look at the example, you see this is pretty easy. So if we look at a set of corresponding sides, like if I look at this side that's 3 feet and 6 feet, those are corresponding sides. So if I was to write that as a ratio here, I'd have 3 feet is to 6 feet. That has to be the same as now any other set of sides between these corresponding figures. So I could take a look now at these corresponding sides, 4 feet and x feet, and I could use that proportion to solve for this missing value. Okay? Just a couple things to notice here. When I set up my proportion here in the numerators, I took kind of the smaller triangle, 3 feet and then 4 feet. Those were kind of the measures in the smaller triangle, and then I made sure I put the bigger measures, or the measures from the bigger triangle, on the bottom. So again, we have to be consistent when we're setting up our proportion. Notice I also could have used these two measures, the 5 feet and the 10 feet, as a given ratio. I could have used that right here as my given ratio as well. Either way, it would have worked. Now let's take a look at an example that will help you understand how to use a proportion to solve for a missing or unknown side in similar figures. Example 4. The following two triangles are similar. Write a proportion and solve for the length of the unknown side. Okay, so they've told us that this triangle, the smaller triangle and the bigger triangle here, are similar figures. And you'll notice we're given this corresponding sides 5 and 8, so I could say kind of 5 is to 8. There's my given ratio there. And now I could use that to kind of solve for this unknown side y. So notice the way I set my original ratio up. I went small triangle to big triangle. So I'll do the same thing here. The small triangle is 10 feet, that side, and then the big triangle is y feet. So now I have a proportion. I could go ahead and solve this proportion for that unknown or missing side length. So I'd look at my cross products here. 5 times y is going to give us 5y. 8 times 10 is going to give us 80. And I divide both sides by 5. Let's finish that 80 out there. Okay. So let's come up here to finish. On the left side, I have y. 5 goes into 80. Well, 5 goes into 40 8 times. So that means I go into 80 twice that. So that would be 16. That's kind of how I came to that answer. All right. Now, I want to make sure I have the right units on here. Notice all the units were in feet, so I'd want to say that y then equals 16 feet. Now it's time to check your understanding of solving for an unknown length in a similar figure. Pause your video player and answer practice question 4. When you're done, hit play to see how you did. Question 4. The following two rectangles are similar. Write a proportion and solve for the length of the unknown side. Okay? So let's see. These are similar. We're going to go 6 is to 2. That has to be the same as 13 is to x. Okay? Looking at the cross product there, 6 times x would give us 6x. The other one, 2 times 13 would give us 26. We're going to go ahead and divide by 6. Divide by 6. Okay, come up here, x on the left side. On the right side, 26/6. I could simplify this into an improper fraction, but I think when we're talking about a length here, it doesn't make sense for us to leave a length as an improper fraction. It makes more sense to write this as a mixed number. So we're going to go ahead and write our answer as a mixed number. So 26 goes into 6 4 times with 2 left over. So that would be 4 and 2/6. Now that 2/6 can be simplified to 1/3, so we would simplify that one more time. 4 1/3 And now we want to make sure we put our units of measure. It looks like everything was in inches, so this is going to be 4 1/3 inches. We can also solve proportions that contain algebraic expressions. So let's take a look at an example here that will help you understand how to do that. So example 5. Solve the proportion 2:5 as x is to 3x plus 1. So again, to solve this, we're going to just use the cross products here. But we got to be careful when we take 2 times this 3x plus 1. We don't want to multiply 2 just by part of that 3x plus 1. We want to multiply that whole thing. So what we want to do when we look at that diagonal is we want to take 2 times that whole denominator there, 3x plus 1. So we make sure we put that in parentheses. The other diagonal is pretty straightforward. That's just going to be 5 times 10. Okay, so let's simplify each of these sides. On the left, I would distribute the 2. So 2 times 3x is 6x, and then 2 times positive 1 would give it a positive or plus 2. On the right side, we get 50. Now I have an equation. I'll just go ahead and solve this. So subtract 2, subtract 2. Let's kind of come up here to finish. So then I'd have 6x equals 48. Divide by 6, divide by 6, and we see that x is equal to 8. That means if I plug an 8 back up in here for x, both of these ratios here would be the same. Okay? Now it's time to check your understanding of this. So go ahead and pause your video player and answer practice question 5. And when you're done, hit play to see how you did. Okay, question 5. We're asked to solve this proportion. So we'll take a look at this diagonal. 4 times 13 on one side. And then 3 times this whole thing, 4x minus 1. So multiplying 4 times 13, we're going to get 52. Distribute the 3. So let's see, 12x minus 3. Okay, trying to get x all alone, so we'll add 3. Add 3. Kind of come over here now. On the left side, we're going to get 55. On the right side, we're going to have 12x. So we'll divide by 12, divide by 12. X is all alone on the right. Now 55 and 12, they don't share any common factors, so I couldn't simplify that. So depending on your instructor, 55 twelfths would be a good answer if they're allowing you to leave it as an improper fraction. If we had to write this as a mixed number, we would say that 12 goes into 55 4 times, and that'd be 48, so we'd have 7 left over, so it looks like 4 and 7 twelfths. So depending on your instructor, either of those answers would be correct.